Hello everyone, this is my presentation on minimum spanning trees. So what is a minimum spanning tree? The idea is to have the lowest possible graph or network. And as you can see in the example above, the green lines show a graph of the lowest costing edges such that all the nodes are able to communicate with each other. As you can see in the example above, this is a minimum spanning tree that has already been made. There are two famous algorithms that can create an MST. The first algorithm we're going to talk about is Prim's algorithm, and then we will discuss Kruskal's algorithm. Both algorithms are greedy and efficient and have different methods of creating an MST, but at the end of the day, they get the work done. In Prim's algorithm, we must select a node. In this case, since we're going in chronological order, we're going to select A as our first node. Once A is selected, we will identify all of the edges A has. In this case, A has 4 edges, and we must pick the lowest costing edge. In this case, we're going to select the edge going from A to F. Since these are the first steps, none of our nodes have been visited before, so we will select the lowest costing edge. However, we generally select an edge that is lowest costing and the edge that will expand our network to an unvisited node. We will repeat and continue to visit the new nodes via the lowest costing edge until the minimum spanning tree is found. As you can see, Prim's algorithm has successfully found the minimum spanning tree by visiting every new node via the lowest costing edge. Now we will discuss Kruskal's algorithm. Instead of selecting the first node, we're going to select the first edge. This algorithm is based on the lowest costing edge instead of the first node via the lowest costing edge. We will continue to select the lowest costing edge and slowly create one tree at a time, slowly creating the minimum spanning tree. Once Kruskal's algorithm has visited every node in the graph, we have now created multiple trees in our system in an unlucky scenario, which is most of the cases. So we must interconnect both trees together to create one network. Now that we have demonstrated two famous algorithms, Prim's and Kruskal's, we will see that Prim's is based on the smallest costing edge of those visited nodes, while Kruskal's is based on the smallest costing edge of the entire graph or system. Both have different time complexities. One way to remember Prim's algorithm is to identify P for pick a node. In conclusion, minimum spanning tree is a data structure that is useful for discovering the least costly network. Minimum spanning trees have two famous algorithms that help us discover what minimum spanning tree of the graph is. Prims is based on visited nodes with shortest edge of unvisited nodes, while Kruskal's is based on shortest edge on the whole graph. Both algorithms have different time complexities and space complexities. Minimum spanning trees have daily useful applications, such as building a cell phone tower network. When lines in certain towers aren't functioning, we need to create a minimum spanning trees to create the most efficient and useful network we can build.